Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the most demanded topic from your side. The topic is matrix vector multiplication using MapReduce algorithm. So basically, we have seen one video on matrix multiplication using MapReduce. You guys are showing so much of love and support on that particular video. I am very much thankful to you all guys. So basically, I want to apologize for one thing, that when I was creating that particular video, I wasn't aware that matrix multiplication, which is seen on the screen, and matrix vector multiplication were not the same. At that time, there was a need of the hour to post the video as soon as possible, and even I was at the learning phase. Basically, when I was creating the video, in that particular video, you might have seen that I have written the title matrix vector multiplication. But in reality, that particular video was totally on matrix multiplication and not on matrix vector multiplication. Now, after publishing that particular video, as soon as I came to know that the matrix multiplication and matrix vector multiplication, both things are totally different, I immediately changed the title and the thumbnail of the particular video and I converted into matrix multiplication using MapReduce. Even many people have confusion between these two. So let me clear one thing. The previous video, that is the old video which is shown on the screen, is on matrix multiplication using MapReduce, in which we multiply two matrices. And this particular video is totally on matrix vector multiplication using MapReduce. Here we are going to multiply a matrix with a vector. So I hope this thing is clear to you all. I hope that as you were showing love to this particular video, matrix multiplication using MapReduce, I'm sure the same love and support will be shown by you on this particular video also, which is matrix vector multiplication using MapReduce. If you still have any doubts between the difference between these two topics, don't worry, it will be clear in this particular video itself. And also the comment section is all yours, you can ask your doubts anytime. So without further delay, let's start with the topic, that is matrix vector multiplication using MapReduce. So for understanding this particular topic, first we need to understand what exactly a matrix and a vector is. So basically a matrix is a 2D array of numbers or symbols which are arranged in rows and columns. Note one thing, that matrix is purely two-dimensional. Two dimensions means it will be having one set of value in one dimension and other set of value in the other dimension, just as rows and columns. You can see one example. Here you can see there is a matrix which is of the dimensions 2 cross 2. Here we have 2 rows and 2 columns. You can see how each and every element is indexed with the help of the row number as well as the column number. You can see the first element is A00, which represents that it lies in the first row and the first column. Similarly the others. So I hope this particular definition of matrix will clear all your doubts regarding matrix. In the previous video, we saw two matrices getting multiplied. Now let's have a look at the definition of what exactly a vector is. So basically vector is one-dimensional array of numbers or symbols which are used to represent the quantities with magnitude and direction. So you can see the major difference is that matrix is of two dimensions and a vector is of one dimension only, which has a set of values. For example, a simple array which has a set of values. Let me give you a simple example of vector. You can see over here we have a vector which is having a single column. Here you can see the values are appended by increasing the number of rows and we are not increasing the number of columns. Here you can see it is represented with the help of a single index number, which is the row number. You can see over here we have two rows. The first is the 0th row and the second is the first row. First element in this particular vector is represented by V0 and the second element in this particular vector is represented by V1. So I hope this particular difference between matrix and a vector is clear to you all. In this particular video, we are going to multiply a matrix which is of two dimensions and a vector which is of one dimension. Let's have a look at the algorithm which we are going to follow, which contains the concept of MapReduce. As you know, MapReduce has two tasks. First is the map task and the second is the reduce task. As you know that the map task is always used to convert the data in the form of key value pairs. So basically, we are going to use a for loop to iterate over all the elements in the matrix as well as the vector which we are going to multiply with it. So here you can see in the for loop we are going to iterate over the value section. That means the values in the matrix as well as the vector. Here you can see the temporary variables I and j are nothing but I is the row number and j is the column number, and a of ij is nothing but the value that is located at that particular I and j value. So basically we are going to emit the I, that is the row number, and we are going to multiply the value, that is a of ij, with the value located inside the vector at the location j. So this multiplication will be the output of the map task. And now we are going to move to the reduce task. So basically you can see over here we are going to assign a variable result which will be having the initial value as 0, and we are again going to use the for loop. We are going to iterate over all the values that we have got from the map task, that is the multiplication of a particular value from the matrix and that particular value from the vector. And once we iterate over it, we are going to add all the values that are going to lie in the same row. For example, if we are talking about the row number 0, so each and every value which are lying inside the row number 0 will be multiplied with each and every value which is lying inside the vector, and whatever is the multiplication output of all the numbers, we are going to add it finally and we'll store it in the result variable. And once we do that, we are going to emit the result in the form of the output. This particular result value will be that particular value after multiplication of the matrix and the vector in the resultant matrix, and this is how we can get the resultant matrix after multiplying the matrix and the vector. I know that the algorithm might not have cleared all your concepts. Don't worry about that. We are going to look into a simple example which will clear all your doubts. But before that, let's have a look at the syntax. So here you can see, let's say we have a matrix of m cross n order. Here you can clearly see that we are having m number of rows and we are having n number of columns. You can see how the data is arranged. You can see the first element is A00, which represents it lies in the row number 0 and in the column number 0. Similarly, if we talk about the last element in the first row, that is the 0th row, we can represent it with the form of A0n, which is the 0th row and the nth column. So I hope the matrix is clear. Now let's move on to the vector. Here we can see that the vector is having n elements and each element is lying in the same column. That means we are having only one dimension over here, and the order of the vector is n cross 1. That means it has n number of rows and it has only one single column. So I hope these two syntax of matrix and a vector is clear to you all. Now we want to multiply these two, matrix and a vector. So for multiplying this, there is a rule that the total number of columns which are present inside the matrix must be equal to the total number of rows inside the vector, which is n. Here you can see n is same. The total number of columns in the matrix is equal to the total number of rows in the vector. That is why we can multiply these two things. And the resultant will be called as m cross v. That is the matrix multiplied by the vector, and which will be having the dimensions m cross 1, because n, that is the total number of columns, and the total number of rows in the vector will be cancelled and the resultant matrix will be m cross 1. So I hope this thing is clear. And now about the value. Let's have a look how value is calculated in the resultant matrix. You can see the first value, it is calculated with the formula summation of j equals to 0 to n a0j multiplied by vj, which means, let's say we want to calculate the 0th element of the resultant matrix. So we have to first see the 0th row of the matrix M. Here you can see, if we talk about the 0th row, we have total n elements in it. So we have to calculate the multiplication of each element in this particular 0th row in the matrix M, and then we have to multiply it with the corresponding nth vector value. For example, A00 will be multiplied with V0 in the vector, and then A01 will be multiplied with the V1 of the vector value. Similarly, it will go on, and finally whatever we are getting, we are going to add it, and that will be the result of the 0th element. Similarly, if we want to calculate the value at the first index of the resultant matrix, we are going to focus on the first row of the matrix M. In that first row, we are having n elements. We are going to multiply every single element in the matrix M with its corresponding index value which is located inside the vector. For example, a10 will be multiplied with v0, a11 will be multiplied with v1. Similarly, a1n will be multiplied with vn, and whatever set of values we are getting after multiplication, we are going to add all of them, and that will be the final value which will be located at the first index of the resultant matrix. Similarly, we are going to find out all other elements like this. So I hope this particular syntax of multiplying a matrix with a vector might have cleared some more doubts that might have popped into your mind. So I hope it is clear a little bit. But don't worry, even if it is not clear, now it is going to be clear with the help of an example. We are going to look into a very simple example, and this example will clear every single doubt. I am damn sure about it. Here you can see that we have seen the algorithm of matrix vector multiplication using MapReduce, and we also have seen the syntax of multiplying a matrix with a vector and how we get the resultant matrix with the help of the formula. Let's have a look how we are going to solve the example. So here you can see that we are having summation j equals to 0 to n, which is a counter which will iterate over all the values from a particular row and the vector. Now in this summation we have a0j, which represents the set of values which are present inside that particular row in the matrix, that is the 0th row. And then it is multiplied by the vj, which is the set of values which are present inside the vector. Now when we try to decode this particular thing, how it will look like, let's have a look at it. So basically you can see the row number 0 is constant. So first the value of j is 0. So the final will be a00, which is this element, multiplied by v of j. V of j means here j value is 0, that is v0. So it is v0 multiplied by a00. Next, since it is summation, we are going to add. So plus, now the counter of j will increment, and after 0, the j value will be 1. So this time it is, instead of a0j, it is a01, and multiplied by, instead of vj, we will write v1 because j value is 1. So a01 multiplied by v1. Now similarly, this counter will increment until it reaches to the end of the total number of elements which are present inside that particular row in the matrix. So the last element will be a0n. Instead of j, we will write n multiplied by vn. So this is how we are going to calculate the value associated at the 0th location in the resultant matrix. Now this was for the 0th location. Similarly, we can do it for the first location, the second location, and we can do it for all m number of locations. So you can just have a look how we are going to do it for the first location also. You can see the algorithm too, it also says us the same thing to do. We are going to finally add all these values, and this particular value will be the corresponding output for that particular resultant matrix. So now I hope this thing is clear. Now let's see the example. Let's say we have a 2 cross 2 matrix in the example, and the matrix has the elements as 1 0 3 2. Let's say this particular matrix is having the name A. You can see in this particular matrix we have total 2 rows and 2 columns. And let's say we have one single vector which is of the order 2 cross 1. Let's say the elements in the vector are 2 and 1. Now this is the given matrix and a vector. We need to find the multiplication of this matrix and the vector, that is A cross V. Since a vector has direction, that is why we represent an arrow above it. So before solving the example, first we should check whether the order of the matrix and the vector follows the rule of multiplication. So let me first write this matrix and the vector with its order, and then let's discuss whether we can multiply it or not. So you can see over here that the order of the matrix is going to be 2 cross 2 because there are 2 rows and 2 columns in the matrix, and the order of the vector is going to be 2 cross 1 because there are 2 rows and there is a single column. you can see the rule says that the total number of columns in the matrix must be equal to the total number of rows in the vector, which is 2, which is the same. Hence we can multiply these two, matrix and the vector, and the resultant will be, after cancelling these two, we are left with 2 cross 1. That is why the resultant matrix order will be 2 cross 1, which means that there will be 2 elements in the resultant matrix. So I hope this particular thing is clear. Here we can represent the resultant matrix with the convention R, and the first element can be represented with the order 0 and the second element can be represented with the order 1. So first element will be R0 and second element will be R1. Now we are going to calculate the value of R0 and R1 with the help of the values present inside the matrix and the vector. Now we have already seen the rule how to multiply it. Let's write the same logic again over here and let's calculate the value. So the logic says that we need to write the summation of j equals to 0 to n. J is just a counter. Now inside the summation we are having this matrix M. First, since we are talking about the 0th location, we will write M0j multiplied by Vj. That is that particular element located at the jth location in the vector V. So let's write what we are getting. First, the value of j is 0, that is why we can write M00 multiplied by, instead of Vj we can write V0. Now the counter will increment and in the next turn the value of j will be 1, that is why we can write M01 multiplied by V1, and finally we will add these two. Now since j value cannot be 2 because there are only 2 elements in the matrix and the vector, that is why we will stop here. Now let's calculate the value of M00, which is the value present at the 0, 0 location in the matrix. It is 1 multiplied by V0, which is 2. Now M01, here you can see the value is 0, and multiplied by V1 at the location V1, the value is 1. So let's calculate this. Here 1 multiplied by 2 is 2 plus 0 multiplied by 1 is 0. So we are getting 2 plus 0 as 2. So here you can see that we have got the R0 value, which is 2. That is why the value that will be present at the 0th location in the resultant matrix will be 2. So I hope this thing is clear how to multiply with the help of this summation formula and get that particular location element. Now we have calculated the 0th location element. Now let's move on to the first location, that is R1. Now here you can see, as per the logic, now we are going to look at the row number 1 in the matrix. So here you can see the logic changes to summation of j equals to 0 to n. This time instead of M0j we will write M1j because we are dealing with first row in the matrix multiplied by Vj. Now you can see over here j value will range from 0 to 1 only because there are only 2 elements. So first it will be M10 because j value is 0 now, multiplied by V0, plus second time the j value will be 1, that is why it will be M11 since there are only 2 elements. So we will write M11 multiplied by, this time instead of Vj we will write V1. As we know j value cannot be more than 1 because there are only 2 elements. So we will stop. Now let's quickly find out that at this particular location what value is present. So at M10 position the value 3 is located, and in the vector V at V1 position the value 2 is located. So let's multiply the value 3 and 2 plus. Now here it is M11 multiplied by V1. So at M11th position we are having the value 2, and at the V1 position we are having the value 1. You can see at M11 we are having 2 and at V1 we are having 1. So let's multiply these two also. So let's write it 2 multiplied by 1. So now you can see over here that 3 multiplied by 2 is nothing but 6 plus 2 multiplied by 1 is 2. When we add these two we'll get 8. So now you can see we have got the value at the R1 position in the resultant matrix, which is nothing but 8. So you can see clearly we have found out R0 and R1 which was required. Now let's fill these particular values in the resultant matrix. and this is how it will look like. Let's write the matrix and the vector again, and this time we are going to write the resultant matrix also, that is having the values 2 and 8 at the respective positions. Now I know everyone has trust issues. You guys might also not believe on me whether this answer is correct or not. So let's go online and check with the help of a calculator that we are correct or not. So here this is online calculator for matrix and vector. So here let's fill the values according to what we had in our example. So it was 1032 in the matrix, and in the vector it was 2 and 1. So now we have filled the values. Now let's calculate the multiplication. So you can see the resultant matrix over here also has 2 and 8 as the values inside the matrix. So I hope now you guys trust me. And with this we are done with the example of matrix vector multiplication using MapReduce algorithm. I hope the entire algorithm is clear to you all. We also have seen the syntax as well as we have seen the example, which might have cleared all your doubts. Please share this video with all your friends, and don't forget to post your suggestions and reviews for this particular video in the comment section. Please do show the same love and support as you have shown to the video on matrix multiplication using MapReduce algorithm in the Big Data Analytics playlist. Please don't forget to like, share and subscribe to my channel. Also hit the bell icon, and don't forget to follow me on Instagram. Also you can join me on Telegram to get updates. Thanks a lot for watching and have a good day ahead.